My second video for the Unit 3 review. We have literal equations here. You are isolating various variables here. So question number 9, we have 2a plus 2b is equal to c. We want to solve for b. So basically undo whatever's being done to b. Take care of addition and subtraction first. Should be able to subtract 2a from both sides. So we're going to get 2b is equal to c minus 2a. And then b is being multiplied by 2, so I divide by 2. Remember, the whole side needs to be divided by 2, so you could write it as c minus 2a all over 2. You could also, remember, you can use common denominators to break up a fraction, so that's the same thing as c over 2 minus 2a over 2, right? Because when you add a fraction, the denominator stays the same, and you either add or subtract the numerators, so these are the same. And this could be written as c over 2 or 1/2 c minus just a. You could knock out the 2's, but I don't think there's anything wrong with just the quantity c minus 2a all over 2. It's just fine, right? Number 10, you might recognize that as the trapezoid area formula, hopefully from geometry. You're solving for the second base here. I don't love the fraction here in front. I know if I double a 1/2 that I can get rid of it, so I'm going to multiply by 2, and I'm going to multiply the other side by 2. So I've got 2a is equal to just equal to h times the quantity b1 plus b2. And again, I'm trying to isolate the b2. I could distribute, but personally, I think, why not just get rid of the h? It's being multiplied by parentheses, doesn't need to be there. So 2a over h is equal to b1 plus b2. And then at this point, we can subtract b1 from both sides. And I didn't set that up very well, I apologize for that. We ended up with 2a over h minus b sub 1 is equal to b sub 2. And again, it could be written a few different ways, but that's a good one. All right, volume equals 2 pi rh. That's interesting. Not sure what that is. It's a circumference formula multiplied by, I'm not even sure that's a standard volume formula. Anyway, whatever formula that is, cylinder volume would be pi r squared h. Pi r squared, yeah, times the height. Anyway, whatever this equation is, we want to solve for r, so we want to get the r by itself. What's being done to r? Well, r is being multiplied by 2, and by pi, and by h. So why don't we divide it by 2 pi h, and 2 divided by 2 is 1, pi divided by pi is 1, h divided by h is 1. We have 1r is equal to v over 2 pi h. By the way, the reason you can do that, remember this was all being multiplied, the 2 pi r h. So you can write it in any order you want. You could have written it as 2 pi h times r. So r was being multiplied by this, and we can divide by all of that. All right, number 12. If you're doing this in 2022, because of your Algebra 1 kind of skipping over some things, you may not see this on the test, but it would be a nice bonus question. Let's just solve for x. And the challenge here is that there are two x's. So I would consider doing something like multiplying both sides by x to get rid of the fraction. So you'll have x plus y is equal to x times z. X plus y is equal to x times z. The little trick here, and you're going to see this in the quadratics unit, you can put every term that has an x on the same side of the equation, and you can put everything else on the other side. So I'm going to move the x over to the right, and that's going to leave me with y is equal to xz minus x. And you might remember from Algebra 1, the distributive property. We can do a backwards distributive property here. Notice these both have an x in common. So I can bring an x out in front of parentheses, and there should be two things left in parentheses that would work out to be the same thing as this. That x would get multiplied by both these values. So what would I want to have in these two spots? Well, x times z would give me xz, like I had down here, and x times -1 would give me the negative x that I had down here. And the brilliance of this is now the equation's written in a form so that there's only one x, which means I can just undo what's being done to x, and I've got x isolated. So x is being multiplied by the quantity z minus 1. I'm going to divide by the quantity z minus 1. And just like that, we find out that z minus 1, of course, goes into itself once, and that means that x is equal to y over the quantity z minus 1.